And welcome everyone to roll call number 5. That's issue 1025 in the Ethereum PMs repo. Link to the agenda is in the chat. Starting off, we had some discussion points on RIP 7212, the R1 precompile. The first is that there was a spec clarification. This hasn't fundamentally changed anything for anyone, and I believe Rollups has checked with everyone who's implemented it to verify that this is correct. But basically, it was a little ambiguous what to do when a signature did not verify, and so that has been clarified in the RIP. So it hasn't because this is final, we obviously can't change anything there. But this was something that needed to be updated. The second is there's been some discussion about the pricing of the R1 precompile. So first of all, as this is a final RIP, that means we cannot change anything about the pricing. If we were to do anything like that, it would need to be a separate RIP, and those who wish to adopt that could adopt that. The reason that some people are interested in changing it, at least to my understanding, is that the R1 curve does not have the same GLV endomorphism that you can use on K1, which makes verification quite a bit more expensive, despite the curves being rather similar. So because of this, it might be worth having a more accurate reflection of the work involved, and this is particularly true for some of the ZK rollups who get closer to the asymptotic costs of these operations. Anyway, just a consideration, so we can have some discussions about that. And if people really do feel that the pricing is not correct, then that would be worth flagging and potentially having a second or another RIP in relation to that. Anyone have other thoughts or additions on pricing or the spec clarification that happened?
I can make a bit comments here.
Yep.
Arbitrum team has raised this concern about pricing of the precompile with this message coming from their benchmarks, and the Optimism team shared that it's not a big issue for them, and if any of the other teams are not very comfortable of the current gas pricing of the contracts, as you said, we can talk about any proposal and talk about how can we change. But in current situation, it looks like most of the teams are okay with the current implementation. And for the clarifications that we have made on the proposal, only Kakarot team's implementation was incorrect due to the current spec, and thanks to their team, we could fastly update their implementation, and it's currently merged, and all of the rollups are aligned with the current spec and the implementation. And lastly, since for the last roll call, the implementation has merged for Optimism code base already live on Polygon mainnet, and yesterday ZK Sync team has launched on their testnet, and possibly we will have on mainnet next week, and congrats to them. It's the first ZK rollup they will be first ZK rollup implementing the precompile on mainnet.
Great. And congrats to everyone who's deployed things. That's very cool.
And I can share one of other concern of the Arbitrum team. if it's okay.
Yeah,
And
one moment, just quickly on the pricing again. So pricing is something we've seen change for mainnet opcodes before. It is something that there's no right answer for, particularly for crypto things where there are like many like very different implementations that are very comparative, and when the whole point of a precompile is to subsidize the cost of performing some action on chain, there aren't any clear answers. So it's just to raise that there is a potential point of discussion, and if you have thoughts on that, it would be worth raising them. Yes, on the other point, I believe you want to talk about.
yeah, my reference implementation on Get use native crypto library of Golang, and they have recently deprecated a function that checks if the point is on the elliptic curve, and the method is still using in their low-level APIs, and still can be used at the same way in all package. But Arbitrum team has concerns that one day we may not be used this method as it's deprecated, it's marked as deprecated now. I just want to raise this concern and take attention to different rollup containers, and you can consider changing this method from native Golang library to another implementation. Or just I would love to hear what do you think about this deprecation?
I mean, for any given precompile / RIP, the implementation it should remain largely orthogonal to these kinds of concerns. So it's definitely worth flagging, and it is something that should potentially be changed if people are worried about in their own implementations, but it doesn't change the way that the RIP works.
Yeah, and it's just my reference implementation.
Yes.
So we may see lots of other implementation even in Get.
Yes, exactly. Yes, Renaud, you going to say
Yeah,
something?
I don't
Post
know
in the chat.
if this is a problem or not, but the fact that R1 is slower than K1 can be seen just at the pseudocode level. It's just that there is a mathematical optimization, which is called GLV optimization, which asymptotically it cuts the cost by 50%. In practice, it's less. And this is why if the same implementer implements the two curves using the same machine and targets, K1 will be faster than R1. So this is not related to I am targeting ARM, Intel, or this or this. It's just that K1 is faster than ED, which is faster than P100-56. And the ratio between the computational time will be the same for each target. It's just that, okay, depending on the implementation, one can be more efficient, but it's a mathematical property that you're able to cut by 2 the size of the ladder on K1. So it's not related to, you can bench, of course, but I can also say that when you will have to implement it in a ZK circuit, K1 will be faster. So I don't have to wait for the benchmark to know it. It's just that K1 has mathematical properties that enable to have some faster execution.
Yeah, sorry if I wasn't clear about that earlier. My points about benchmarking were just that there are no clear answers exactly for gas costs, but yeah, the endomorphism definitely like makes a difference here in terms of cost. Any further points on 7212? Nope. Okay. Moving on. The next topic is RIP 7696, which is a alternative method of achieving faster crypto within the EVM, particularly by offering a precompile for generic double scale multiplication. So I believe that someone is here on the call who wishes to present.
Yeah, I would like to share my screen, but I cannot.
Absolutely. Yeah, I do need to enable that. Stand by one moment. I believe you should be able to share screen now.
Yeah, perfect. Can you see it?
Not yet. I see your wallpaper.
Okay. Okay, I think my PDF reader just crashed. Okay, it's here.
There we go.
You can you see it?
Yes.
Okay, cool. So RIP 7696 is about generic double scalar multiplication, which is the core operation for signature verification, but many other cryptographic protocols. So this is what you require if you want to verify either ED, EDDSA, ECDSA, perform steel signature, and so on. So right now we have several different RIPs for each time targeting a different elliptic curve. So question is, shall we choose for each new use case, and how hard would it be to address genericity? And this is something that we would like to propose, and we want to push it progressively. So this is why we perform the Solidity implementation to provide proof of concept. We will compare it with the current implementation and address what it would mean for Node and Zk EVM. So right now we are talking about RIP 7212. So there are several startups which started to build Upon using account abstraction in conjunction with P100-256, mainly for Sweet UX. So Candid Wallets, Clave, which is here. Demo is very fair over P256, and Smooth, which I belong to. Another use case is using the SGX for the settlement of a layer 2. So this is something zkSync and Scroll and Taiko have been implementing. So what happened is that SGX previously was implemented over a BN curve, but recently it has switched to P100-256, which is good if 7212 is implemented, but also we should notice that we are really dependent on the GAFAM choice for the choice of implementation. So right now, what the part of Fido that is implemented is a P100-256, but we have no clue that at some point they will not do the same that was done from SGX. So as for instance, at 255.19 is already part of T50 of Fido 2. We don't know if, I don't know, maybe next year we will not be able to sign using P100-256, but have to use ED instead. So this is a limitation of the RIP being non-generic. There are also some criticism around this curve. It's not transparent. There is actually a bounty to find the seed, which have been lost. It's also weak considering a misuse. So it's not deterministic, while the EDDS spec is. It's not MPC friendly, and it's slower than K1, so we just talk about it. So what we are pushing, so we want genericity. It would also enable to implement RAP 7212, but ED, most other more general protocols, so ring signature, still address as specified in ERC 5564, Palaker, Vesta, Baby Jujube, which is used in the Circum framework. And actually, if you look at what we are doing, there is many use of Circum, but sometimes we are using a ZK verifier while a simple classic verifier would be enough, and we are using a hammer to crush a fly. And also, if you have double scalar multiplication, you can implement Pedersen hashing. So this means you can have a friendly ZK hash function, because hash functions are expensive for ZK layer 2s, and this is something that will be reflected by the proposal of increasing the cost in EIP 7667. Other use cases are bridges to other ecosystems. Darknet has its own curve, Cosmos, Solana. So mainly the concern are the code complexity. So actually, if you want to have a generic curve implementation, all you need is a Montgomery multiplier and implement the ACC formulas. So this is something that you should already have in most library or ZK EVM implementation. So what 7696 includes, there are two hub codes. So if you look and compare it to 7212, the difference for the first source code mainly lie in the introduction of the curves parameter. So P, A, B, N, which are specific fields for each curve. And we propose also another precompile, which taking only 4 extra values, enable a speedup which is comparable to GLV we was talking about. So mainly GLV is performing 4 bases multi-exponentiation, and with this extra data, we can restore performances comparable to what we reached with the K1. So those optimizations are independent of the language. It's if we look just at the complexities, the number of operation, it would be the same independently of is it implemented in a node, in a circuit, or in Solidity. We'll talk about the result in Solidity next. And a question I've been asked about why pushing this instead of a full generic MSM. Actually, I think a full generic MSM might be too complex to have a chance to be implemented, while if you look at the Solidity code of the proposal, it's close to 100 lines. So, of course, full generic MSM would be superior, but too complex, I think, for a single RIP. So last year, we had several results about Solidity implementation. So what we want to say now, if we look at the best 7212 implementation in considering the performances, was reached by FCL last year. And what we were able to do, actually, we managed to have a faster implementation than what FCL was doing, being specific, but for a generic curve. So if we can do it in Solidity, it can also be transposed to other languages. So mainly what appears on the two last lines are the cost for the two precompile in full Solidity. So for circuits, just to give an insight, so there is also a problem when pushing one EIP or RIP introducing a new curve, each time it's a pain, because it means that a dedicated ZK circuit will have to be implemented by the layer 2. So this is something ZK Sync has done in Yule. We have contact with Linea. Actually, they plan to integrate our Solidity, which mainly is quite the same as using Yule. And we think that pushing something that is generic would avoid to redesign a new circuit each time a new use case or a modification is pushed by the GAFAM. Yeah, so as I said, Montgomery multiplier is what you need to implement those. It's already coded in GNARC. Actually, they pushed, and ZK Sync, it's also what they did to implement 7212. It could be modified to be generic. So that's it, because I had only 5 minutes. I think I've done more.
Thank you very much. I have a few questions. One is on, you mentioned using, providing the extra like 4 bases for speed ups where possible. Do you have any insight into the gas of that? Because obviously then you'd have to supply the extra points versus the speed up there.
Yeah, so first you can do this off chain. Actually, this is what is done when we provide the public key for your 7212 verification. Actually, you already have to make some kind of wrapper to transmit from the result of the enclave to the blockchain. So this can be done off chain. So on chain is something like, I think it's 120K gas, which would be a one-time computation, but it would be clever to perform to do this off chain instead.
Okay. The next question I have is, how does this compare to something like EVM Max in terms of the functionality would gain and sort of the gas comparisons? Do you have any thoughts on that?
Yeah, it's kind of different, because we would have to have a full EVM Max implementation. Is that EVM Max is more generic, but it's not to be used by a non-cryptographer guy. It means that using EVM Max, you can design a lot of cryptographic primitives. It's a powerful RIP, but it's intended for cryptographer only. I think if I ask you what would you do yourself or developer with EVM Max, it's not obvious. So EVM Max, it's a very good RIP. Clearly, if we add it, I would use it for many use cases. I think that using EVM Max, you could also, for instance, implement lattice-based primitives. It's another toolbox. EVM Max, it's a kind of trade-off between EVM and EWASM, which at some point was a very good project, because EVM language is far from the machine, which is complicated. Why do we need all those precompiles? Because we do not have EWASM. So EVM Max is very good. It's kind of a trade-off between EWASM and EVM, but I would say that it's a lower level tool than a precompile.
So outside of the implementation issues around EVM Max, because you obviously have to, for example, implement Montgomery multiplication on chain or like in Solidity using EVM Max. So assuming the implementation side of things was not an issue, i.e. someone wrote a really robust EC multiply library or something like that. Do you have any insight into just sort of the gas costs? Like how much worse is it to implement like Montgomery multiplication using EVM max versus to sort of emulate this RIP of yours?
I would need some off-chain time to make an evaluation, but
yeah, I mean, I think part of the issue is you also don't have those concrete numbers for EVM max too, and if we do, they're rather old numbers, so isn't a fair answer there. I was just wondering if you had any thoughts.
I could answer it, not right now, but give me 1 or 2 days, and I will have you the answer.
That would be really helpful. Thank you. Dogan in the chat asks, "Oh, can you repeat the gas costs for R1 using ECML add?"
Yeah. Yeah, it's the same for any curves. So what we had last year was 200K, and using the second opcode, we were able to reach 160K. So it's 20% less.
Okay.
Right now, this line was the fastest on-chain verification, first line of FCL. And we can keep the same performances being generic or cut it by 20% using the extra data.
Basis.
But this 20% will be closer and very close to 50% for ZK implementation and also at node level. In fact, at node level, you should have the same performances as K1. Actually, ZK, because when you perform a single operation on a ZK on a circuit, you have a very high number of operations just to implement a modular multiplication, and you are very, very close to the asymptotic limit. So this is something that we were able to measure on Starknet last year before when we started to work on the R1 before 4337 came to Ethereum.
Great. Anyone else have further questions on this topic? All right. Thank you, Renat, for the presentation.
Thank you.
Pretty cool idea. Yeah, I mean, the idea of having very generic implementation or very generic ways of doing things is this extensibility of that is very appealing. Next topic on the agenda is a bit of a discussion of what has been happening on the L1 side of things. There's since the last roll call, there's been lots of discussion around what gets included in the next L1 fork Pectra. So I'm gonna hand over to Ansgar, who has some points he'd like to bring to everyone's attention on the L2 side.
Yeah, thanks. I thought that was maybe just a nice addition to roll call to use this platform to basically give brief summaries of like the parts of the Aqueduct procedures that of last month that were somewhat relevant for layer 2. So I just prepared that for today. So there are kind of five different individual topics I would want to touch on quickly. The first 3 are concerning the upcoming Pectra hard fork towards the end of this year, and then 2 of them kind of are more on the roadmap beyond that. So on Pectra, the first one, and that's a very recent one, is on account abstraction. So basically, the there's the EIP 3074 that maybe most here are familiar with, that was, after a lot long debate, accepted for the upcoming Pectra hard fork initially, like a month or so ago. There has been quite a bit of debate since, though, because there are some drawbacks of the EIP that not everyone likes. And so specifically yesterday, there was a breakout call on the kind of future of account abstraction on layer 1. And now there is an alternative EIP, a very new one, and it's basically just like an iteration of 3074 called 7702. And so basically, I just wanted to signal here for people who maybe are not following this super closely that layer 1 is very likely to ship one of those two in the upcoming hard fork, and so that we will have basically enhanced EOA features on layer 1. And what that means, of course, is that given kind of the default setting power of layer 1 that it still has, and given that EOAs, of course, still make up most of the user base, that this will basically create a pretty strong kind of forcing function towards users expecting this functionality. So if you're layer 2, you have not looked into this deeply yet, I would recommend that you have a look. You basically have some sort of EOA to account abstraction strategy in place. Presumably the decision between 3074 and 7702 will be made over the coming weeks. So I'll give another update on the next roll call, but also you can, for example, tomorrow's RollCall devs, this will probably be a big topic. So if you want to listen in on that, or maybe you can come and contribute, that also is worth it. And as a last point on that account abstraction topic, of course, given that the layer 1 version of such a spec change usually is like a pretty strong default Schelling point for also the variant that ends up landing on layer 2s, now would be the time to look into, is there maybe any modification to the spec that you would want to make it more useful in your context, and then come and try to participate in the layer 1 governance process around that as well. I could imagine specifically on the ZK side, for example, it'd be really helpful to know if there's like any maybe small modification that will make it much easier to have that also implemented on the ZK side. So that's on the kind of the account abstraction front. And I'm not sure how to do this. Maybe after each topic, I'll briefly ask if there's any kind of questions. So like if there's any questions specifically on account abstraction, now would be the time. Okay, otherwise I'll move ahead. So the second point I just also wanted to briefly mention, we already talked on this call earlier about the about 7.2.12, the one precompile, but just wanted to mention that it's now also officially considered for inclusion for Pectra on the L1 side. And that's especially exciting because that would be the first time that a feature that was first shipped as an IIP, and it's already finalized, of course, as an IIP, would then later on come to mainnet. So there's a lot of open questions that we would then basically have to figure out. Both just with the basics, like will it use the same EIP number as the IIP, but also like more interesting things like, will L1 use the spec as is? Will there be some small changes? For example, we talked about the gas pricing, these kind of things. Like if there are changes, basically how does that impact the relationship between layer 1 and layer 2? These kind of questions, they'll all be figured out in the coming week, depending on, of course, if it actually ends up being accepted for Pectra or not. But again, if we of course always I'm usually participating in these RollCall dev calls if I'm trying to represent the kind of the layer 2 perspective as best as possible, Carl as well. Of course, if there's ever anything specific, it would be great, like to also have people directly from the layer 2 side participate. But again, just wanted to flag that. Third one, the last one, that one, just a quick update, EOF. Just because that's a bigger change. So if you at some point would want to support that, that would probably require some lead time. That one is still considered for inclusion for Pectra, but is more contentious. So for now, I would not necessarily expect it to be included in the hard fork, but that might change in the coming weeks. And if we end up including it, then that's also something where at least you should have a strategy around. Would you want to ship that then as well? Of course, at some point, Solidity, for example, then would start using that as a default. So if you want to still be compatible with new Solidity versions, you probably have to also support that. So basically, at least having some sort of strategy for that in place and tracking that, I would recommend. So those are kind of the three main points on the upcoming Pectra fork that I wanted to briefly summarize. And then beyond Pectra, there are two more things. One would just be local trees. We've talked about this in the past here on RollCall already a little bit, but now with Pectra mostly locked in, also Verkle, which will likely be the upgrade after Pectra, basically is starting to be more and more top of mind for people. There's DevNets, there's active work, which means that you as layer 2 should really probably start to have some sort of Verkle strategy. Like, are you going to move over to Verkle as well? If once mainnet does that, are you not going to do that? Like, what are the implications of, for example, forever being on a different commitment scheme than stake commitment scheme than layer 1? These kind of questions. Are there maybe, again, same topic as with account abstraction, are there maybe small modifications to Verkle that would be really desirable from your point of view, so that then it would be more attractive for you to move to? And those would probably have to be raised on layer 1 relatively soon, because I think we reasonably soon get to the point of having basically like a more or less a spec lock-in for Verkle. So now would be the time to dive in and pay attention to this. And then the last topic to bring up would just be 4844 and post 4844 block throughput scaling. So just as an update, we are now, what, 2 months or something after the fork, roughly. We still haven't reached basically the target throughput for 4844, which means the blobs are still effectively free on mainnet, which is nice, but of course that won't last forever. So basically the way layer 1 thinks about blob scaling is that it will basically be a gradual scaling. So we are already working on data availability sampling, which is the technology that will unlock more substantial scaling. This might or might not arrive in time for Pectra. If it doesn't arrive in time for Pectra, we would probably just have like a small bump up of the existing kind of numbers to give us a small kind of constant throughput increase over what we have today. And then once we have data availability sampling in the form of PIADAS, that's a specific technology that we're using there, then we can kind of like have probably also gradual, as we kind of get experience with that, but more ambitious kind of throughput increases. The reason why I'm bringing it up here, I mean, for one, of course, is that that's maybe relevant for you to plan out your data availability strategy. But also, I do think that there's a little bit of uncertainty on the one side around the demand levels for blobs. So as I was saying, right, we still haven't even hit the target for 4844 yet. And of course, this has multiple dimensions. One is just the amount of throughput that existing layer 1s that already use on-chain DA, Ethereum L1 on-chain DA can basically can make use of. But then also there might be other chains that today do not use Ethereum on-chain DA, but are considering switching over to it. But they, of course, would need some sort of reliable, credible path where they can trust that won't blow back up in cost. And so having a good feeling for how much demand is there beyond the current levels would be very helpful. I think right now, for example, I keep pushing for this as a priority, but like I don't think all core devs agree that basically it is a big priority, given that we don't see the demand yet. So I think basically just clearly voicing that there would be demand beyond current levels, and that should really be a priority, and that basically scaling should really push at the fastest possible speed. I think if you think that's the case, right? Or of course also the other way around, if you think that current levels are basically that we can take it easy and focus on other things first, both of those perspectives I think would be very valid. And so basically like making those more visible for layer 1, I think would be very helpful. Yeah, so those were the points I had. I hope I'll keep doing these summaries on the next roll calls if they're useful. Are there any specific kind of questions to any of these specific points? Let me answer the chat. Yeah, Roberto, I definitely agree that my assumption is also that we will basically reach the target probably even before Pectra. I would say that it's almost inevitable that there will be some small bump up in throughput in Pectra, but it could be very moderate. It could be very conservative if there's no clear signal that basically more is necessary, because it might be pre-PIADAS. So it would just use the existing technology, just basically pushing it a bit more to its limits. So if there's no clear signal that there is strong demand, I would expect that the Pectra bump will be relatively small.
Yeah, all that makes sense, Ansgar. Thanks. Just wanted to note, we plan on increasing basis throughput a bit more because we're currently at target, so we're going to consume a bit more of that space. And I also see a lot of L2s that are coming online, so it seems very likely we'll be hitting that target quite soon.
Yeah, makes sense. And I think basically the sooner L1 basically actually starts reaching that target level and the block base fee goes beyond zero, I think the more likely it is that we get a bit more of the throughput increase, both already in Pectra, but also that I think that one is not even the one that I'm mostly focused on. I think the more important lever here is to what extent the work on PRDAS gets prioritized by clients already today. I think to the extent that they feel that there's some priority that should be put on this, we'll just get there sooner. And that's the one that's going to unlock almost a substantial increase. Okay, yeah, then that's all from my side.
Thanks, Ansgar. That's all we had on the agenda for today's call. Does anyone have any other topics they would like to discuss before we bring this call to a close? Going once, going twice. Okay. Thank you everyone for attending. Next roll call will be in roughly a month's time, and see you all there. One quick last thing to flag is that Ansgar and I will be looking into spinning up breakout calls again after next roll call. So if you have any topics that you'd like to see discussed there, please reach out to either one of us. And yeah, thanks everyone for attending.
Thank you.
Thanks.
Thank
Bye,
you.
everyone.
Bye.